Hello guys, welcome to the course Inorganic Made Easy. So as the name suggests, this is going to be a course which is going to make the study of inorganic chemistry very easy for you because the students really find it very difficult. Actually, it's not difficult, but there are so many reactions and so many stuff that you just have to learn. So you find it very difficult. And here we are going to really help you make that study easy. And the topics that we are taking up in this playlist of ours are going to be those topics which are very important for the competitive examination, especially for JEE and NEET. But it is also going to be helpful for the students who are going to be appearing for the various other examinations like NET and GATE also. So all the topics that we are taking over here, they are important from the examination point of view. And if you're going to learn them in an easy way, well, you're going to obviously score a lot more in your examination. So what is the topic that we are going to discuss today? Well, we are going to be learning about the nature of oxides. And when I'm talking about the nature of oxides, what we will be learning specifically in this lecture is about the acidic, the basic, the amphoteric, and the neutral oxides. Now, if you look at the previous year JEE and NEET examination questions, the questions that you will be finding related to this topic is going to be, well, what are the various trends for the basic character of the oxides, the trends for the acidic character of the oxides. You will be given a list of compounds and then you will be asked to identify which are acidic oxides or which are basic oxides. You can be asked which of them they are going to be amphoteric oxides, which are neutral oxides. Right, so these are going to be the very important questions and very frequently they are being repeated in the examination, but even then the students, they find it difficult to attempt this question. Why is it so? The reason for this is that oxygen, this is the second most electronegative element that we have, and it is combining with all the elements of the periodic table, leaving aside a few noble gases. In fact, in the noble gases also you will be finding the compounds of xenon with oxygen, even krypton with oxygen. So we have so many elements combining with oxygen to form oxides, and then we have to tell which of them they are acidic, which of them they are basic, amphoteric, and neutral. So students, they really find it difficult to learn that, and then obviously they are not able to attempt in the examination. So we are going to make you understand first of all the concept, and then we will be giving you trick to remember these acidic, basic, amphoteric, and neutral oxides. And at the end of the lecture, I'm going to share with you a few questions which have come in the JEE and the NEET examination. And because we have done the whole study by then, well, I'm sure you will be able to answer all of them yourself without even just looking back what you just learned in the lecture. So therefore, this is going to be really very helpful for you, and this is going to help you fetch 4 marks in your examination. Very important, vital 4 marks. So I am Dr. Ritu Johar, your educator from the channel H2O, the A to Z of chemistry, and I hope you're going to really benefit from this lecture. In fact, I'm 100% sure you're going to benefit from this lecture. So let us begin the study. So first of all, let us classify these oxides. We have basic oxides, we have acidic oxides, we have amphoteric, and we have neutral oxides. Now, what do we mean by these terms? First of all, what are basic oxides? Well, this is going to be an oxide which when combined with water, this gives off a base. All right, a basic oxide, when we are going to react that with water, the compound that is going to be formed is going to be a base. Next we have is acidic oxide. So acidic oxide is going to be that oxide which when combined with water is going to give off an acid. And amphoteric oxides, well, they are having properties both acidic as well as basic. So when they are going to be reacting with a base, then also they will be forming a compound, and when they will be reacting with an acid, then also they will be forming a compound. So these are amphoteric oxides. You can say they are in between the acidic and the basic oxides. Okay, and then we have the neutral oxide. So neutral oxide is going to be that oxide which is neither going to exhibit an acidic character nor it is going to exhibit a basic character. They will not be reacting with acids, they will not be reacting with base, well, they will not be reacting with water also. All right, so let us look at the examples of these and understand them a bit better. So let us see them one by one. We have first of all basic oxides. So basic oxide is going to be that when combined with water which gives off a base. For example, we have Na2O. So when we are going to add water to it, what it will be forming is NaOH, and NaOH, you all know, sodium hydroxide. This is a base, right? So when the hydroxide is a base, well, the oxide is also going to be basic in nature, or when you can say that the oxide is basic in nature, the hydroxide is also going to be a base. Okay, so that will be also basic in nature. Next, let us see one more example. We have calcium oxide. So calcium oxide, add water to it, what it will be forming is calcium hydroxide. So calcium oxide is a basic oxide, and calcium hydroxide, this is also basic in nature. So this is also a base. Okay, so you are understanding. Next we have is acidic oxide. So acidic oxide is going to be which, when added to water, this gives off an acid. For example, we have Cl2O. So when you're going to add Cl2O to water, what you will be getting is ClOH, or a better way to write it would be HOCl. This is hypochlorous acid. So this is an acid. So when we have an acid, the oxide is also going to be an acidic oxide. A better example I can give you, which is more familiar to you people, is going to be SO3, sulfur trioxide. When you're going to add water to it, what is formed? H2SO4, and all of you know this acid very well. This is sulfuric acid, the king of all acids, right? So when we are combining a oxide with water, which gives us a base, it is called as a basic oxide. And when we combine an oxide with water to give us an acid, this is called as an acidic oxide. Next, we move on to the amphoteric oxides. So an amphoteric oxide is going to be that which is going to exhibit both acidic as well as basic characters. For example, we have zinc oxide. So add zinc oxide to water, what it will be forming is zinc hydroxide. Now, what is zinc hydroxide? Let us see. Well, first of all, let us add NaOH to it. So when we add NaOH to it, what it forms is sodium zincate, and along with that water. All right. And then we add an acid to it. It forms zinc chloride along with that water. Okay. So here this is basically an acid-base neutralization reaction where a salt and water is formed. So here when it is combining with NaOH, this means zinc hydroxide is acting like an acid. Okay, so zinc oxide is going to be an acidic oxide, and here when it is reacting with an acid, it is acting as a base. So this means this is basic and the oxide is going to be basic. So therefore we can say that zinc oxide and zinc hydroxide, they are both having acidic as well as basic characteristics, and when an oxide and hydroxide are going to be such, they will be called as amphoteric compounds. Okay, I hope this is clear. The next we have is now neutral oxide. So neutral oxide, this is going to exhibit neither acidic nor basic characters. Okay, so for example, we have carbon monoxide. When we add water to it, there is no reaction taking place, no compound is going to be formed. Similarly, when you're going to add NaOH to carbon monoxide, no reaction taking place, and when you're going to add HCl to it, also no reaction taking place. So a neutral oxide is going to be which is not forming any compound with water, not reacting with acid, not reacting with base. It is neutral. Okay, so these are the four types we have. And now very importantly, what you have to learn is the various strengths for these, which is going to be more basic, which is less basic, which is more acidic, which is less acidic, identifying them, which is going to be a basic oxide, which is acidic oxide, from the whole list we have in the periodic table. So now let us learn about these strengths one by one. So now as far as the trends they are related for the acidic and the basic nature of the oxides, well, you have to learn two types of trends. Number one is going to be when the element which is combining with oxygen, that is different. For example, you have to compare the acidic or the basic strength of lithium oxide, sodium, potassium, rubidium, cesium oxide. You have to tell which is going to be the most basic, or you have to tell which is going to be the most acidic, or you have to just arrange them in the ascending and descending order of the acidic or basic nature of theirs. All right. For another example, if we take, we have magnesium oxide, aluminium, silicon, phosphorus, sulfur, and chlorine oxides, and you have to again tell which is going to be more acidic or more basic, arrange them in ascending or descending order of these. So these are when the element which is combining with oxygen is different. Okay, and the other, when you have to learn the trend, is going to be when the element combining with oxygen is the same, but it is in the different oxidation states. For example, we have N2O, NO, N2O3, NO2, N2O5. In all of these 5 oxides that we have for nitrogen, well, nitrogen is going to be in a different oxidation state. And then you will have to tell which is going to be more acidic and which is going to be more basic. So we will be learning these over here because they are very repeatedly asked in the examination. So first of all, we will begin with type 1, when the element combining with oxygen is going to be different. Okay, and here you will be learning essentially 2 types of trends. One is going to be the oxides of a group and the other is going to be the oxides of a period. So first we are learning about the element which is combining with oxygen when it is going to be different, what is going to be the trend, and I will be explaining you what is happening in a group, what is happening in a period with the help of just 2 examples. One is going to be Na2O and the other is Cl2O. Na2O, you all know, when we put this into water, it will be forming NaOH, and NaOH is a base, therefore this is a basic oxide. Okay, on the other hand, we have Cl2O. When we put into water, we get HOCl, so apochlorous acid. So this is an acid. What I've done is just written it in a opposite order. So chlorine comes first, O, and then H, so that we can just compare now NaOH and ClOH. In this, oxygen, oxygen, hydrogen, hydrogen. Only difference is between this element Na and this element Cl. This element Na, when it is there forming a bond with OH, it is becoming a basic hydroxide, whereas when it is a bond between Cl and OH, this is a acidic hydroxide. Okay, so this is what we can say. Okay, so now I can replace Na by any element which can form a basic hydroxide, and I can replace chlorine by any element which is forming an acidic hydroxide, or you can say it will be an acid that it will be forming. Okay, so here we have AOH to be a base and here we have AOH to be an acid. Now why it is a base? Because it releases OH ions. Why this is an acid? Because it releases H positive ions. But now the question is, why is this releasing OH ions and why is this releasing H ions? Right? The reason for this is that here the bond between A and O is breaking off, and here in the acid the bond between oxygen and hydrogen is breaking off. Okay, now the next question is, why is the bond between A and O breaking and why is the bond here breaking between O and H? And well, the answer to that is the electronegativity difference of these elements. Okay, so if now the electronegativity difference between oxygen and the element A is going to be greater than the electronegativity difference of oxygen and hydrogen. Okay, so when this difference is more over here, well, this means that oxygen will be exerting a greater electronegativity effect on this shared pair of electron. It is going to pull the electron pair towards itself. What it will be forming is A positive and OH negative. Whereas if the electronegativity difference of oxygen and hydrogen is going to be more than the electronegativity difference of oxygen and the element A, well, then the electronegative pull of oxygen is going to be more on this pair of electrons. It is going to pull the electron pair towards itself. What it will be forming is AO negative and H positive ions will be released, and therefore this is an acid and this is a base. Okay, now let us put this. So this is essentially a basic hydroxide when the electronegativity difference between oxygen and the element A is going to be more. When the electronegativity difference of oxygen and hydrogen is more, then it is going to be an acidic hydroxide. Let us put this now in the example that we have taken for NaOH. So in NaOH, the electronegativity values of the 3 elements according to the Pauling scale, we have a sodium is 0.9, oxygen is 3.5 and hydrogen is 2.1. Okay, so just take out the electronegativity difference. What you will be finding is that electronegativity difference of oxygen and sodium is going to be more than the electronegativity difference of oxygen and hydrogen. That is why oxygen has pulled the electron pair from this bond and it formed Na positive and oxygen. Okay, on the other hand, if you take, so what does this mean is, sorry, that oxygen sodium bond is going to break easily, releasing OH ions. Fine. On the other hand, we have ClOH. So here with the chlorine, we have the electronegativity as 3, 3.5, 2.1. So you can understand very easily that the electronegativity difference of oxygen and hydrogen is more than the electronegativity difference between oxygen and chlorine. Okay, and therefore this is forming the breaking of what bond? This bond. This bond breaks. So OH bond breaks. It is releasing H positive ions. From this, what do we conclude? What we conclude is that A is a less electronegative element, and over here the A is a more electronegative atom. Okay, so you can understand also that sodium is going to be less electronegative and chlorine is going to be more electronegative. So when we have an oxide where the element combining with oxygen is less electronegative, it is forming a basic oxide, whereas when it is going to be a more electronegative element, it is forming an acidic oxide. Okay, so let us now just generalize all of this on a table. So this is the gross. We have the S block, the D block, the P block, and the F block elements. And here we have a sodium, and here we have a chlorine. Okay, so now what is sodium and what is chlorine? We all know that sodium, this is a metal, whereas chlorine, this is a non-metal. All right, so what is happening? The metallic properties, they are decreasing from left to right in the periodic table, right? So the metallic properties, they are decreasing, and the non-metallic properties, they are increasing. And also you can say that the ionic character of the compounds that it will be forming is going to be decreasing, and the covalent character will be increasing, because the metals, they generally form ionic compounds and the non-metals, they generally form the covalent compounds. All right, so this is one thing clear. All right, now the next thing, you all know that sodium is going to be largest in size in its own period, right? So this is going to be having the lowest ionization enthalpy in its period, whereas chlorine, this will be having the highest ionization enthalpy if we just leave behind the noble gases, right? So this is we know that the ionization enthalpies, they are increasing as we are moving from left to right. Okay, and what about the electronegativities? We have already seen that sodium is less electronegative, chlorine is more electronegative. So this means if from left to right, the electronegativity values, they are increasing. Okay, now what we have learned is when the electronegativity value is less, it is going to be a basic oxide, and when the electronegativity value is more, it is an acidic oxide, right? Sodium oxide is basic, chlorine oxide is acidic. So this we can also infer as that the acidic character of the oxide is going to increase from left to right, and the basic character is going to decrease as we are going to move from left to right. Clear? So in a period, now I think this is clear. So sodium oxide, this is going to be basic. As we are going to move in a period, we are moving towards more acidic oxides and less basic oxides. Okay, let us now understand the same things in the group also. Now, as we are going to move down in a group, what is going to be happening is that the metallic properties, they are increasing. Why? Because the ionization enthalpies, they are decreasing, right? The size is becoming larger, and it is more easy to remove the electron. It is more easy to move the electron. So that means the ionization enthalpies, they are decreasing. When the ionization enthalpies are decreasing, the metallic properties, they are increasing. And also we know that it is going to be more electropositive as we are going to go down the group. So this means that the electronegativity values, they are decreasing down. Now when the electronegativity values, they are decreasing down, this means the lower down, this is going to be a more basic oxide, and upper will be a more acidic oxide if we are talking about in relative terms. So we can say that the basic nature of the oxides is going to increase down the group. The acidic nature of the oxides is going to decrease down. Okay, so I hope now this is clear as far as the oxides, they are concerned, that when we are going to move from left to right, the acidic nature is increasing, and when we are going down, the basic nature of the oxides, this is increasing. Clear? So from this, what we conclude that is along a period, the acidic nature of the oxides is increasing, and down the group, the basic nature of the oxides is increasing. For example, now, if you have to compare the third period oxides, so we have Na2O, MgO, Al2O3, SiO2, Pu2O5, SO3, Cl2O7. So we are saying that these are the oxides of the same period. So when they are the oxides of the same period that we are comparing, it will be as we are going to move in a period, the acidic nature of the oxides will be increasing. So you can see over here that sodium oxide and magnesium oxide, they are basic. Al2O3 is amphoteric, and all these non-metallic oxides, they are acidic in nature. Okay, next let us see one more example. We have Li2O, BeO, B2O3, CO2, N2O5. So these are the second period oxides, and again we see that Li2O is basic, BeO is amphoteric, and B2O3 carbon dioxide, N2O5. These are all acidic oxides. So as we are moving in a period from basic to acidic, and in between we have amphoteric compounds. Okay, if we look in a group now, we have group 1, so Li2O, Na2O, K2O, CS2O, and rubidium oxide. All of these, they are basic, but the basic character is going to be increasing down the group. Clear? Okay. Now there are some important points which I would like to share with all of you people. Most of the metallic oxides, first of all, they are basic. Why they are basic? Because we know that the metals, they are electropositive elements. Their electronegativity values, they are going to be low. For example, we took off sodium, right? So when we have the metallic oxides, most of them, they will be basic, but some can be amphoteric. For example, we have ZnO, Al2O3 to be amphoteric oxides. The next, in general, the alkali metal and the alkaline earth metal oxides, they are going to be basic than the oxides of the D block elements. So this should be easy, because first we will be having in the period the alkali metals, then the alkaline earth metals, and then the D block elements will be coming. So in a period, the oxides basic character is decreasing. Next, the oxides of the lanthanoid elements. Please remember, all of the lanthanoid elements, they form basic oxides, and the basic character again is going to decrease as we are going to move left to right. Okay. The next, the nature of the hydroxides is very similar to the nature of the oxide. If the oxide is going to be basic, the hydroxide will be basic. If the oxide is acidic, its hydroxide will be acidic. If the oxide is going to be amphoteric, the hydroxide will be also amphoteric. For example, Na2O and NaOH both are basic. Then we have Si2O and SiOH4, they will be both acidic, and Al2O3 and AlOH3 going to be amphoteric. And again, if you have to arrange them, the hydroxides also in the acidic basic order, it is going to be just the same way that you have learned for the oxides. Next thing, in the aqueous medium, the acidic oxides, they form acids. So we have NO2 first water, it will be forming HNO3, and SO3 plus water, it will be forming H2SO4. So from this, you can also understand that the acidic oxides, they are called as acid anhydrides. Okay, so we have an acid from which we have removed water is going to be the acidic oxide, and it is called as acid anhydride, acid from which water has been removed. Okay, so these are certain important points. So now let us move further into our discussion. Now the next we have is when the element combining with oxygen is going to be the same but in different oxidation state. For example, we have carbon monoxide and carbon dioxide. So in both of the cases, the element is the same, that is carbon. Now which one is going to be more acidic, which one is going to be more basic? For this, what you have to remember is that higher is going to be the oxidation state, more is going to be the polarization, and more is going to be the covalent character. And if the covalent character is going to be more, more is going to be the acidic character of the oxides, right? So what you have studied in case of again Na2O and Cl2O was that Na2O was an ionic compound and this was a covalent compound. Okay, this is more acidic and this is more basic, right? So more covalent character means more acidic character. And when we is going to be having a higher oxidation state, the polarization is more. Where did you learn about this polarization? Well, you learned it in chemical bonding when we were discussing the Fajan's rule. In case you have not studied that well, you can just open up our playlist on chemical bonding and study the lecture on Fajan's rule. You will be having a thorough understanding of the concept. Okay, so higher will be the oxidation state, more will be the polarization. More polarization means more covalent character. Okay, so we will be having more acidic character of the oxide. So acidic nature of carbon monoxide is going to be less than that of carbon dioxide, because in carbon monoxide we have +2 oxidation state, whereas in carbon dioxide we have +4 oxidation state for carbon. Okay. Similarly, if I have to talk about SO2 and SO3, here the oxidation state for sulfur is going to be +4 and here it is going to be +6. So again, sulfur trioxide is going to be more acidic than sulfur dioxide. If you now compare all the oxides of nitrogen, I just write down the oxidation states of all nitrogens. So in N2O it will be +1, NO will be +2, N2O3 will be +3, NO2 will be +4 and N2O5 will be +5. So the oxidation state is increasing as we are moving from N2O to N2O5, and therefore the acidic character will also increase. Okay, and what we find is that N2O and NO, they are neutral. N2O3, NO2 and N2O5, they are all going to be acidic. Which is going to be the most acidic? It will be N2O5. Another thing you can remember over here is about carbon monoxide. So carbon monoxide is also a neutral oxide. We have just three neutral oxides. One is carbon monoxide and these other two are going to be N2O and NO. These are the only neutral oxides that we have. Okay. Now another one example which I would like to show you is for the oxides of manganese. Okay, so what we have learned is that as the oxidation state is going to increase, the acidic character of the oxides is going to increase, the covalent character of the oxides is going to increase. And here you can see also that we have MnO, right? It is going to be in the +2 oxidation state, Mn3O4. It is going to be in +8/3 oxidation state, Mn2O3, +3 oxidation state, MnO2, +4 oxidation state, Mn2O7, +7 oxidation state. So the oxidation state is increasing, the ionic character is decreasing, the covalent character is increasing, the acidic character is increasing, and the basic character, this is decreasing. We find that MnO, this is going to be basic in nature. These three, they are going to be amphoteric, and Mn2O7, this is going to be acidic in nature. Now Mn3O4, please do remember this is a mixed oxide. Okay, so it is an oxide which is made up of MnO dot Mn2O3. And this is amphoteric in nature. Similarly, we have Fe3O4. So this is going to be made of FeO dot Fe2O3, and this is also going to be amphoteric in nature. Okay. Now that you have understood all the concepts related to the oxides, what is going to be the trend in the groups, what is going to be the trend in the period, and you have also seen that if an element is in multiple oxidation states, then what is going to be the trend? Well, even then, you are going to be facing some difficulty in attempting questions when not a trend has been asked, but individual oxides, they are given to you. For example, you are given Na2O, it is given to you, and then it is zinc oxide, it is given to you, and then it is Al2O3, it is given to you, and Sb2O5, it is given to you. So there are going to be so many oxides, and if individual they are given to you, well then again you will be facing a problem because there are so many oxides and you will be finding it difficult to remember all the oxides, which one it is going to be. Trends, now it is going to be easy. Okay. So for that type of questions, what are we going to do? Well, now what we will be doing is we are going to classify these oxides in a different way, and then we will be putting up which one out of these are going to be acidic, basic, amphoteric, and neutral. Okay, so what you are going to do is that you will be classifying now the elements of the periodic table into three types, which you all know: metals, metalloids, and non-metals, and their oxides. Okay, so if you do not remember, the metalloids of the periodic table are germanium, arsenic, antimony, tellurium, and polonium. These are the 5 metalloids. And please do remember, very importantly, that boron and silicon, they are non-metals. Okay, generally at many places I have seen that it is given as metalloids, but it is clearly mentioned in the P block elements class 11th chemistry book that boron is a typical non-metal, as well as silicon and carbon, they are non-metals. It is very clearly written in the NCERT textbook group 13 and group 14. So please do remember, these are the only metalloids that we have, and out of this, polonium is radioactive, so we do not study the oxides of that. So only 4 metalloid oxides are going to be possible. Okay, now what we will be doing is that once you have identified it is going to be a metal, metalloid, or a non-metal, then you are going to be seeing Let us start from this side, non-metallic oxides. So in case of the non-metallic oxides, just remember that we have three oxides to be neutral, that is carbon monoxide, NO2 and N2O. So these are the three neutral oxides. Apart from these, all the oxides of the non-metals, they are going to be acidic in nature. Easy enough. It is going to be Cl2O, it is going to be Cl2O7, it is going to be N2O3, it is going to be N2O5, it is going to be P2O5. All the oxides of the non-metals, they are going to be acidic in nature. Okay. Next, just let me clear this out. All the oxides of the metalloids, they are going to be acidic in nature, except that we have three oxides which are going to be amphoteric in nature, and that is going to be TeO2, As2O3 and Sb2O3. These are going to be amphoteric in nature. Otherwise, all the oxides of the metalloids are also going to be acidic in nature. Okay. Next we have is the metallic oxides. In case of the metallic oxides, just check the oxidation state. +1 to +7. What is going to be the oxidation state? In case of the +1, +2 and the +3 oxidation state, most of them, without leaving a few exceptions, they will be basic in nature. +4 oxidation state, all of them will be amphoteric in nature. +5, +6 and +7, they will be acidic in nature. Moving about the exceptions, in case of the +2, we will be having BeO, ZnO, SnO, PbO to be amphoteric in nature. In case of +3, it is Cr2O3, Al2O3 and Ga2O3, which are going to be amphoteric in nature. And in case of +5 oxidation state, V2O5 is going to be amphoteric in nature. Okay. Now, well, I hope now you all understand. In case of the metallic oxides, you can classify basic oxides, +4 amphoteric, +5, +6, +7 are acidic if you just leave out these amphoteric oxides. In case of the metalloid oxides, all are acidic. Again, leave out a few exceptions. And in case of the non-metal, we have just neutral and the rest are going to be acidic oxides. So now, if I tell you a trick to remember the amphoteric oxides, and then you just have to remember these main headings, well, I think it should be easy for you people. So let me now give you a trick to remember all the amphoteric oxides that we have, and the rest then it is going to be very, very easy for you. So the trick that we are going to learn to remember the amphoteric oxides is going to be a mnemonic. What is the mnemonic? This is a mnemonic in Hindi, and well, I will give you the English meaning of that also. So do not worry about that, but just try to remember this mnemonic because this will help you learn most of the amphoteric oxides. Okay, and the mnemonic says, जनाबे अली गाए सुना करें वो सभी आसमान के 3533 प्रभु. This is 3533 प्रभु. Janabe Ali is referring to some high person Ali who is singing, and all the prabhus, that is 3533 lords of the sky, they are listening to his song. That is what it means. Okay, and how you are going to correlate it to the amphoteric oxides is going to be the list of these elements which form the amphoteric oxides. Okay, I'll just write it in the English also. And all the yellow ones, they are the symbols of these elements which are going to form amphoteric oxides. So first of all, we have Janabe. So in Janabe, we have zinc and beryllium. Ali is for aluminium. Then we have Gaye is for gallium. Suna is tin. Kare is for chromium. वो से vanadium, सभी is for antimony, arsenic is asman, K is just for making sense of the mnemonic, and 3533, well, this is standing for the oxidation state of these last four. Chromium in the +3 oxidation state will be forming amphoteric oxide. Vanadium in +5 oxidation state will be forming amphoteric oxide. Antimony in +3 oxidation state will be forming the amphoteric oxide, and arsenic in also +3 oxidation state will be forming amphoteric oxide. And Prabhu is God, which means Pb for the Prabhu. Okay, so this is going to be lead. All the oxides of lead, all the oxides of tin, Okay, then gallium, aluminium, beryllium, zinc. So these are all the elements which form amphoteric oxides. Along with these, there are going to be some others. Please do remember that all the metals in +4 oxidation state, you have just now learned, they were all amphoteric. So you have to check the oxidation state. If they are in +4 oxidation state and it is a metal oxide, so they will be amphoteric. And along with that, there are going to be two more which I could not fit into this mnemonic. That is going to be TeO2 and In2O3. Okay, so tellurium oxide and indium oxide. So these are the ones which are going to be amphoteric. So this is the complete list of all the amphoteric oxides. And if you have learned this, well, then it is going to be very easy for you people to tell which one will be basic oxides and which one will be acidic oxides. So I am going to now show you two tables, one for the S and the P block elements and one for the D block elements, and just try to put this concept over there. Okay. So this is the table that we have for the oxides of the S and the P block elements. So now if we want to apply this trick, first of all, think we have the +1 oxidation state. And in the +1 oxidation state, if we have the metals, well, all of them, they will be making basic oxides. For example, if you want to look at the group 1 elements, all of them, they are making basic oxides. Right now, if you move on to group number 13 elements, they are generally seen in the +1 and the +3 oxidation state, where the +1 oxidation state, they are seen in the lower elements because of the inert pair effect. So we find In2O and Ti2O in the +1 oxidation state, and you can see both of them, they are what? They are basic oxides. So you do not have to mug up the whole thing. You just have to put the concept into your mind and apply that. Okay, then we have the +2 oxidation state for the metals. There you have learned that most of them, they are going to be basic, but again that you have to just remember the list of the amphoteric ones. So in group 2 we have beryllium oxide. You have just now learned the mnemonic Janabe Ali. So Be was beryllium. Okay, then if you look at group number 14, in group number 14, well, we have lower down again +2 oxidation state possible because of the inert pair effect, the common being +4. Okay, so +4 and +2 are there. So we can see over here SNO and PBO. And both of them, they were in our amphoteric oxide mnemonic. Okay, so that was what? Janabe Ali gaye suna kare wo sabhi asman ke 3533 Prabhu. So in that, Suna was SN and Prabhu was PB. So this we have again SNO and PBO, both of them amphoteric, and along with that you've also learned that all the metals in the +4 oxidation state, they are going to be amphoteric. So you can see SNO, SNO2, PBO, PBO2, all of them, they are amphoteric compounds. Okay, so this is how you are going to apply this trick. You do not have to mug up anything. In one of the questions that I saw, there was asked, what is the nature of SeO2? So you just have to know where is this placed in the periodic table. So if you know that, well, this is going to be in the oxygen family, and oxygen family means halogens, and halogens means what? Halogens mean it is going to be a non-metal and it is going to be acidic oxide. Okay, so this is how you're going to learn it. So TeO2, we have already learned that this is going to be a metalloid, and metalloid, they are going to be mostly acidic oxides. But again, TeO2, I told you, you have to remember that this is going to be amphoteric oxide. Then we have learned that As2O3, this is going to be amphoteric. Sb2O3, these are going to be amphoteric. Okay, so this is how you can use this table and remember the concept. Just take a printout of this and put it onto the wall of your room, and just keep on seeing that and just remembering the trick, and you are going to master the concept very well. So this is the list that we have for the 3D element oxides, and do remember that it is only for the 3D elements that you have to learn it. You do not have to do it for that 4D and the 5D series, also not for the lanthanoids or the actinoids it is required. For the lanthanoids, I've already told you that it is going to be all basic oxides, but the trend for the basic character is going to be decreasing as we are going to move from left to right. Okay, so I hope that is clear. Now for the 3D series, again, these are transition elements, these are metals. Okay, and these are metals, so you are going to use the concept for the metals only. So +1, +2 and +3 oxidation states, they are generally going to be basic. Only you have to remember the list of the amphoteric oxides. +4 is going to be amphoteric only, and +5, +6 and +7, they are going to be acidic oxides. Again, you have to remember the exceptions. So +1 oxidation state, no problem, right? +2 oxidation state in the list, Janabe was zinc, right? So zinc and beryllium. Janabe means zinc and beryllium. Okay. So zinc is going to be as an amphoteric oxide. Then we have chromium. Again, it was in the mnemonic we had. So it is going to be again amphoteric. All four plus oxidation states, they have to be amphoteric. In the +5, there was just one exception, and that was V2O5, which is going to be amphoteric. And then +6 and +7, they are going to be acidic. Okay. Now, if I ask you what will be Bi2O5, okay, so you just have to remember that it is going to be a 15 group element, lowermost element, and this is metallic in nature. And metallic in nature, +5 oxidation state for bismuth is not a very stable oxidation state. Generally, it will be found in the +3 oxidation state. And the most stable +5 oxidation element for bismuth is going to be bismuth fluoride, BiF5. But we do have Bi2O5 also existing, and if it is in the +5 oxidation state and it is not in our list, this means what is going to be its nature? It is going to be acidic in nature. Okay. Whereas if I ask you Bi2O3, what it would be, just let me write it down. Okay, so Bi2O3 and Bi2O5. So this is +3 oxidation state, so this is going to be basic, and this is +5 oxidation state, this is going to be acidic. I hope now this is clear to you people. This is just not mugging up and just remembering each and everything with this beautiful little trick that we have for you people. Okay, so now I hope the concept is clear. You are going to make a printout of all this. And when you have made it out, you are going to put it onto your wall and you are going to just have a look at it every day before your exams. And it is going to be perfectly correct in your exams. And most frequently this question is coming in the exams. So now let me show you a few questions from JEE and NEET examinations, and we will be just checking up how much we have learned in this lecture. So question number 1 that we have is the amphoteric oxide is going to be Na2O, SO2, V2O3, ZNO, and this is a AIEEE 2003 examination question. So this is All India Engineering Entrance Test before it was being called JEE. Okay, so we are going to attempt this question. I hope now this should be very easy for you. You just have to look at the amphoteric compound list that we had, and you will find that, well, it is going to be zinc oxide, that is going to be amphoteric. Okay, so the correct option over here is going to be D choice. Next, the amphoteric hydroxide, and this is the JEE Mains 2019 question. So you have to just simply remember that if the oxide is going to be amphoteric, the hydroxide is also going to be amphoteric. So can you quickly tell me which is going to be it? Yes, it is going to be B choice. Beryllium oxide is amphoteric from the alkaline earth metal. So beryllium hydroxide is also going to be amphoteric. Next we have is the acidic, the basic, the amphoteric oxide respectively are the choices they are given to you, and this is the JEE Mains 2020 question. Okay, so I hope you are understanding the importance of this concept. So, well, first of all, we have to look at the acidic oxides. So acidic oxides, they are going to be which one? They can be either the metalloid oxides or they can be the non-metal oxides. Okay, so first of all, you can see over here we have Cl2O, so non-metallic. Yes, this is going to be acidic. N2O3, yes, this is going to be acidic. We have just N2O and NO, which are going to be neutral for nitrogen. The rest, all three oxides, they are going to be acidic. MgO, this is going to be basic, and N2O3 again, so this is going to be acidic. Okay, so out of this, C choice has been eliminated. Next we have to see basic. So calcium oxide is going to be basic, Li2O is going to be basic, and SO3 again sulfur non-metal, so this is going to be acidic oxide. So this one goes, so we have A and B to be ruled out. Next we have amphoteric, so P4O10 and Al2O3, phosphorus is a non-metal, and Aluminium, this is the metal in +3 oxidation state, but this is in the list of the mnemonics. Janabe Ali, Ali was aluminium. So the correct option is going to be B choice. Okay, so I hope now it is very, very easy for you people with the help of the tricks. Now the next question that we have is amphoteric oxide. So amphoteric oxide, the choices we have are calcium oxide, carbon dioxide, SiO2 and SnO2. So you again simply have to remember the list of the amphoteric oxides. And well, what is going to be the answer? Well, it is going to be D choice. All oxides of tin, they are going to be amphoteric in nature. Either it is going to be SnO or it is going to be SnO2. Okay. All right, now question number 5. Which of the following order represents the correct sequence of increasing basic nature of the given oxides? And this is a AIEEE 2011 question. The NEET students, do not worry. The next 3 questions, they are from the previous year NEET examinations. So you will be seeing those also. And even the questions that I have taken up from the JEE examination, similar questions, they were in the NEET examination. Which of them is an amphoteric oxide, which is a basic oxide, which is an acidic oxide. So they were repeated questions. So I've not put all the questions, but they are in both examination, JEE as well as NEET examinations. Okay. So now in this question, well, if you look at the compounds that we have a magnesium oxide, potassium, aluminium and sodium oxide. So what you're supposed to do is just arrange them in the periodic table, right? So we have sodium, we have potassium, we have magnesium and we have aluminium, right? So in a period, we know that the basic character is going to decrease. So sodium is going to be the most basic, right? And in a group, the basicity is going to increase. So potassium is going to be more basic than sodium. So what should be the order? First of all, it should be potassium, then sodium, then magnesium, and then aluminium. So the correct option over here, if you're going to match it, well, it is going to be B choice. We have aluminium less than magnesium oxide, then sodium, and then potassium. Okay, so I hope now it is very clear. Great. So let us see now a question from the previous year NEET examination, that is AIPMT 2003. And the question is, the basic character of the transition metal monoxides follows the order. All right, so you know the basic character is going to decrease left to right in the periodic table. So what you need is only to remember the order for the 3D series. Okay, and if you know that, well, the answer is going to be correct for you people. Well, the correct answer over here is going to be D choice. Now, I'm just going to share a mnemonic that I learned to remember the 3D series. If you remember some, yours, it is going to be perfectly well. Okay, so the mnemonic that I have is science teacher very cruel, man, fear, cow, and nice cute zebra. Right? So science is scandium, T is going to be titanium, V is vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. So these are the metals, and then the basic character is going to decrease from left to right in the periodic table. Okay. Now question number 7, this is from AIPMT 2006. The question says, which of the following oxides is not expected to react with sodium hydroxide? So which oxide will not react? Well, it has to be a basic oxide. If it is an acid, right? So acid reacts with a base to form salt and water. So this is what we call as the neutralization reaction. So base we have as NaOH. So this side we should have an acid, or we can have an acidic oxide. Okay, or it can be an amphoteric oxide also, because we know that the amphoteric oxides, they are also going to react both with acids as well as base. So it is only going to be a basic oxide which will not be reacting with sodium hydroxide. So you have to just simply tell which of these is now a basic oxide, right? So calcium oxide, yes, this is going to be basic. Calcium is group 2 element, this is the metal, and metallic oxides, they are basic in nature. SiO2, well, this is going to be non-metallic in nature, so this is going to be acidic oxide. BeO2, this is going to be amphoteric, and B2O3, again, this is going to be non-metallic oxide, so this will be also acidic in nature. Okay, so the correct answer is therefore going to be A choice. Calcium oxide is not going to react with sodium hydroxide. So moving on to the last question for today, which I think now should be perfectly clear with you people, a very easy question which has been asked in the NEET 2020 examination. You simply have to match the oxide with its nature. The oxide given is carbon monoxide, barium oxide, aluminium oxide and Cl2O7. Okay, so I hope now this should be very easy for you people. So carbon monoxide, this is going to be neutral. So we have three neutral oxides, carbon monoxide, N2O and NO. Barium oxide, barium is group 2 element. It is metallic in nature, metal oxides in +2 oxidation state. It is going to be basic in nature. Then we have Al2O3. It is in the list of the amphoteric oxides. So Ali is going to be amphoteric, and Cl2O7 chlorine is a non-metal, non-metallic oxides. They are acidic in nature. Okay, so I hope now the concept is sealed perfectly in your mind. हेलो, गुड मॉर्निंग बेटा, क्या हाल है? बेटा उठा रही हूँ बेटा उसको, पर उसने भी पहले अपने वो बाल वॉश कराने जाने। That would be all for this lecture. See you again for the next lecture where we will be discussing more tricks, more concepts and more questions. If you have any doubts related to this lecture or any other concept of chemistry, please feel free. Post your doubts in the comment section or you can mail them to us at h2ochemistry@gmail.com. If you've liked the lecture, please do click on the like link and also do subscribe and share. This will help us reach more students like you. So see you again for the next lecture. Bye bye. Have a nice day.